Hello, and I would like to perform a calculation having to do with electric power dissipated by an electric resistor. So let's start off with the knowns of this problem, and that is a cauterizer, which is used to stop bleeding in surgery of a patient, so a living patient, this could be a human or an animal, puts out 2.00 milliamperes from an applied voltage of 15.0 kilovolts. A. What is its power output? B. What is the resistance of the path? Okay. Well, let's put everything in SI units here first. So we know that we have 2.00 milliamperes. That's an electric current. So I should equal to, and that's going to be 2.00 times 10 to the minus 3 amperes. Also note the voltage, we could call that delta V, is 15 kilovolts. Kilo is the metric prefix for thousand, so that's 15,000 volts. Okay, we want the power output. Now, power output, given we have current and voltage, is going to be simply capital P equals I times delta V. There's a little multiply there. So we can just multiply those numbers. It's 2.00 times 10 to the minus 3 power amperes times 15,000 volts. Okay? So let's go ahead and use the calculator to calculate this. Okay? So let's clear. Let's move this over. This is going to be, let's see, 2 times 10 to the minus 3 times 15,000. Okay, so I've still got this in scientific notation mode, so I probably just want to go back to normal mode. So this is exactly 3 times 10 to the first, which is 30. And let's write that down. That's going to be 30. And the units would be watts, because that's the unit of electric power. Notice that's the SI unit for power. Also note that an ampere is a coulomb per second. Also note that a volt, sorry for that, a volt is a joule per coulomb. So, coulombs per second times joules per coulomb, you get joules per second, energy per time, which is power. That's watts. Okay, great. Next, what's the resistance of the path? Well, since we have this power calculated already, we know that power has two other versions. It's also equal to current squared times resistance. It's also equal to voltage squared over resistance. Okay? So we can use either of these forms. Why don't we use, say, this first form? Okay? So why not? So power over current squared should be resistance. And we'll put the numbers in. So that's 30 watts divided by, the current was 2.00 times 10 to the minus 3 amperes, and we have to square that to get the resistance. Okay? So let's go back to the calculator. And again, we'll move over so we can see this. Okay. So we have, let's see, let's do alpha F1 to get N over D, which is that stack. So 30, and that's going to be over 2 times 10 to the minus 3, there we go, and then squared. Okay, so let's write this down. Okay, So this is, and let's maybe go to scientific notation. Second quit. Go back up to here. Enter. Enter. Okay, it's 7.5 times 10 to the 6th. So this is 7.5 times 10 to the 6th ohms. That would be the correct answer in SI units. Now, many times resistances are expressed in kilo ohms or in mega ohms for large resistors. Okay, so we can say this is about 7.5 mega ohms. Mega is the metric prefix for million. Mega ohms. Okay, so that ends this problem. Thank you very much for your attention. Hope this makes sense about how to calculate for electric power. Please smash that like button if you enjoy this content. Please subscribe to the channel to grow the channel. Please share this in your sphere of influence. And thank you very much for watching. I will see you in the next video.